Problem number 2. The driver of the compact car in the previous problem suddenly applies the brakes hard for 2 seconds. As a result, an average force of 5.0 times 10 to the positive 3 newtons is exerted on the car to slow it down. For letter A, what is the change in momentum, or equivalently, what is the magnitude and direction of the impulse on the car? For letter B, determine the momentum and velocity of the car now. So let's check our solution. So first, we will write the given again. For your force, we have the 5.0 times 10 to the positive 3 newtons. For the time, we have 2 seconds. And for the mass, which came from our previous solution, that is 725 kilograms. So velocity is equal to 115 kilometers per hour from the previous problem. So for the formula for your impulse, for letter A, that is your force multiplied by your given time. We are going to apply is negative because the movement of the given force of the car along the x-axis is positive, and to slow it down, we need a force given of 5.0 times 10 to the positive 3 newtons. That's multiplied by the given time, 2 seconds, minus the initial, that's 2 minus 0. So we will have 2 seconds. So we will get a value of negative 1.0 times 10 to the positive 4 newton seconds. For letter B, your initial momentum that we solved before from the previous problem, that is 2.32 times 10 to the positive 4 kilogram meter per second going eastward. And we have also a formula for your impulse, which is your force multiplied by the change of time is also equal to your change of your momentum. So that is your final momentum minus your initial momentum. Deriving the formula to get the final momentum, we can substitute the values of negative 1.0 that we got here times 10 to the positive 4, that's kilogram meters per second, the same as this one, plus the 2.32 times 10 to the positive 4 kilogram meters per second, or we solved from the previous problem. So your PF now will get a value of 1.3 times 10 to the positive 4 kilogram meter per second eastward. But we also have a formula for your final momentum, which is also your mass multiplied by your final velocity. So we need to solve for the velocity. So if you're going to transpose those formulas, we'll get a VF, or your final velocity, is equal to your final momentum divided by your given mass. So we have the final momentum of 1.3 times 10 to the positive 4 here, divided by the 725 kilograms, which is given from the previous problem. By solving that equation, we will get a value of 18 meters per second, or that is 65 kilometers per hour eastward.